In this series of videos, we're going to be introducing a bunch of core concepts of the course. We're going to be talking about data, we're going to be talking about visualization, we're going to be talking about design elements, and we're going to be talking about Tableau. And in particular, how all these different facets of our course kind of integrate and relate to each other right from the very beginning. So to motivate this, it's pretty clear actually. It's really fundamental. It's fundamental to a data scientist job. This notion of data visualization, and in fact, we can perform data visualization at two phases of the kind of analytics lifecycle: at the very beginning and at the very end. At the very beginning, we're often concerned with what we call exploratory data analytics. When we explore a data set, more often than not, we're visualizing the data. We're visually inspecting the data set for interesting trends, strange values, overall patterns, relationships between variables, like things like this. And this is for our benefit, for our data understanding before we sit down, for instance, to a more formal modeling approach, like a predictive analytic approach or machine learning approach. We might want to first understand the data that we're dealing with, so we have a good idea of what techniques might work well and what might not have as much promise. On the other hand, we often use data visualization at the very end of our kind of product lifecycle. And in this case, our main objective is to communicate technical findings to non-technical stakeholders. So we often think of these as our downstream consumers. With our machine learning team or our predictive analytics team, we've gone through and really made a lot of good value, a lot of value add from the data set, but we need to communicate that value add to people that don't know machine learning stuff. They don't know predictive analytics stuff. We need to show them why this is so valuable. And often things like dashboards and reports, these types of things can help these results sing in a way that things like static metrics or write-ups may often not. So we're going to talk about both sides of this, the beginning side and the end side. And there is some overlap, but you do need to be careful when you're designing a visualization, as we will throughout the course, to specify which one of these you're working on. Is this an exploratory thing or is this a presentation thing? Because the techniques that work in one might not work in the other. But we'll talk more about this as we go along. Now, how do we actually do this? Well, there are two broad camps of solutions for visualization, whether it's exploratory or downstream consumer, and they are solutions that require coding knowledge, programming knowledge, and solutions that don't. Each one of these has their pros and their cons, and when you're designing a course like this, you have to make this decision right up front. Are we going to go with a programming language, or are we going to go with a no-code or low-code option? In this course, we're going to go with low-code, but let me lay out the pros and cons for each one. Let me give some examples first. So like ones that would require some coding knowledge, for instance, we would have things like ggplot in R. We would have things like Seaborn or Matplotlib in Python. We'd have D3 in JavaScript. Pick your poison. On the low code, no code, we'd have things like Power BI, Alteryx, Tableau, these types of things. We're going to work with Tableau, but it's just a choice. So the good news with no code and low code, it's easy to adopt. It's fast, as we'll see. Like we'll make a visualization in this series of videos, our very first one, because it's fairly straightforward. Now, the problem with low code or no code is that there are inescapable difficulties that are getting swept under the rug by the coding platform or the visualization platform. And if you are not very careful, you can be showing complete garbage, like total nonsense, because you're not forced to think critically about what's going on underneath. So a lot of what we're going to be doing in this course is just asking ourselves, what is this visualization showing me? What is Tableau actually doing? So that you do not ever get in a position that you're in front of a client and they say, now, what does that data point represent? And you find out to your horror that you actually don't know, which I have seen students do. I would like to avoid in the future. Okay, so on the code side, what are the good parts and the bad parts? Well, the good parts is you have to specify exactly what you want, and that's very powerful because these languages are incredibly flexible, and you can specify exactly what you want almost regardless of what that is. You have tons of control over every minute detail, and that's a good thing. And it's also a bad thing, right? Because you have to specify everything, and you have to know the syntax and the code and how this package relates to the broader coding ecosystem in order to make any kind of progress. So it doesn't make sense for a course like this, in my opinion. Although I use these packages in my own research and in my own work all the time, things like Seaborn and Python in particular, or Matplotlib in Python. So if you're interested, please let me know. But for this course, we're going to be talking about Tableau. Now, I have tried to teach Tableau many times in many different situations. And for the longest time, I had the same, like the same outcome every time. I would be teaching Tableau and some version of the following comment would come out. It's like, I feel like I'm just trying stuff and nothing's working. Like, I feel like I'm just throwing stuff on this visualization and I don't know what I'm doing, and I don't know, and it never works right. It never looks like the ones I see online. I don't know. And this is, as you can understand it, as I perfectly well empathize with, is really frustrating, right? It's super, super frustrating to feel like you are just trying random stuff and that there's no process, there's no framework. And it dawned on me that there was a whole series of preliminary lessons that we needed to talk about before we could even really dive into Tableau. And this course is going to do that. The big idea is we need to have that framework in place so that we, when we do get to the Tableau part, are in complete command of a lot of foundational and fundamental content. They'll make the Tableau part much easier. In particular, if you're feeling like this, or just in general, you should always be asking yourself the following questions. What is the specific context-driven business question that I care about? Like, it's not ever enough to just start throwing variables together. It's like, what are you trying to do? And we'll give examples of what that means. Given that you have a question at hand, what data do you have at your fingertips that might help you answer that question? So you have a data set, you have a question. What's kind of like the overlap of that Venn diagram? What are the data that tell you something about this particular story? And then once you have an idea of what the data are, what chart type best depicts those particular fields? And that's not an opinion. That's like there are right answers and there are wrong answers. So you come up with a question, you tie the question to the data you have, and then given the data you're going to be looking at, what's the best chart type to display that? And we'll go through each one of these pieces individually to kind of lay out what to do. So how about the first one? What specific context-driven business question are we going to be looking at? So this often requires some sort of domain knowledge. So by domain knowledge, we mean knowledge related to the problem that you're working on. So if you're working on a retail data set, for instance, you have to have some knowledge of retail. If it's a foot traffic in stores, you have to know something about how that works. If it's app downloads or engagement or something like this, you have to know something about that app ecosystem. Regardless, it's all to say that you can't be doing this type of exploratory data analysis or even machine learning in general, typically speaking, in a vacuum. You have to have that domain knowledge. Now, either you have it yourself or you're paired with some like specialized, subject domain expert, either within your organization or the client that you're working for. That relationship is often really powerful because sometimes your ignorance of the topic and their expertise in the topic can kind of play off of each other because you're coming at it with completely fresh eyes and they have some really interesting ideas that maybe they've wondered about but have never had the technical tools to explore. And so the combination of those two things can be really, or the interplay between those two things can be really powerful. For our purposes here, we're not going to have subject matter experts on hand for all of the data sets we're going to be working with. It's too difficult in an academic setting, even if it's very common in industry. So instead, what we're going to be doing is working with data sets where the context is pretty darn clear. Like things that we can all relate to, like a bike share data set or an online data set, a retail data set where it's fairly straightforward what's going on. There's no kind of technical terms that we don't know or things like this. So one last thing I want to say is that when you're looking at this data set, there is one inescapable difficulty that you just have. I mean, there's just no way of kind of memorizing facts to get ourselves out of this problem, or knowing a particular tool in Tableau to get ourselves out of this problem. It just is critical thinking, and that is ask questions. You are business analytics master students or MBAs. Like the business part should be the part that, like, this is your kind of ideas. Like, well, if you were running this business, if you were the entrepreneur running this business, what questions would you have? What kind of things would you be interested in? That's there has to be a spark there, and that's the one thing that we can practice asking these questions, but you have to get in the habit of asking them. And like I said, we're going to be doing that over the course of the semester. So how do we distinguish a bad question though from a good question? When we say a good context-driven business question, what does that look like? Well, let's start with a bad question and work our way forward. So a question that's not very good is, what are the company's sales like? Okay, so that's just too broad. Sales of what? Sales of what, when, over what, channels, among what customers, things like this. A better question might be, what are the top 5 product categories in terms of profit in Q1? So notice we've changed a bunch of things here. We're not just saying sales, we're actually saying profit. So that takes into account cost of goods sold. So this is a huge thing. How big are your margins? We're not looking at the entire portfolio. We're just looking at the top, and we're not looking at any period of time. We're looking at just Q1. So notice that how much we've narrowed this thing down. It often, especially when you're starting out on a visualization, helps to have very, very specific questions. You can always broaden it out later and say, well, what if I change Q1 to Q2, or top 5 to top 10, or not net profit but total sales, or things. You can change these things later, but starting more specific helps. Another thing we could ask is, what's the proportion of total time that people spent on each one of these different channels, so mobile or web or in person, and then kind of what did that drive at the end of the day. Again, it's all about being as specific as you can, narrowing the question down rather than keeping it broad. So the other thing I want to point out right off the bat, and this is an unfortunately persistent problem both in business and in academia. It's a problem that we see a lot, and it's this fear of what we call negative results. By negative, I mean you don't find anything even if you look. And I want to instill from the very, very beginning a strong belief that negative results are good. They're very, very good. So you might ask yourself, is there a significant difference between customer lifetime value, CLV, for mobile users and in-person shoppers? This is a question, okay? And it's a question that data can help us answer. So imagine we go through our exploratory data analysis and we construct some visualizations and show that there is a difference. That's great. Okay, so now we know that, like, for instance, in-person shoppers spend more than mobile shoppers. That's great. Now we know. And we can quantify those differences and say how big those differences are and in what places they are different. But imagine we look at this and say, is there a difference in CLV between these two groups? And the answer is no. No, there isn't a difference. That's great. That's really good. It's awesome that we know that, because we don't have to worry about it anymore. Like, one of your problems as a manager or a data scientist or whatever you end up doing is that there are going to be too many good things to investigate and too many interesting directions in which to push. Negative results help us close doors. They help us close down avenues of inquiry, and that's really, really important, because if we have complete freedom all the time, we're kind of in trouble. Like, we might just sit there and spin our wheels. So negative answers are totally, totally fine. So as we go through the course, or even each week, we're going to follow a pretty particular pattern for developing each one of these tools. We'll start with I do. So in class, oftentimes it'll be me showing you how to do things, and whether that's a technical skill or like a particular type of computation, a particular type of visualization or something like this, or whether it's a soft skill, like here's how I approach a data set when I haven't seen it before. I'll show you how I do this. I will be doing it. On the homework, it's much more like a we do, in the sense that I might guide you through that process. And on those weekly homeworks, you'll be doing the work, but I'm kind of scaffolding out what you might do, how that might work. And then finally, in the cases of the course, so these mini cases that we're going to do, those cases, it's really you. Like, it's laid out as if you are a consultant. Here's a data set, and it's really on you to go through this particular data set, ask the questions, develop the tools, and report the results. So hopefully this kind of structure where we spread things out between I do, we do, and you do will help kind of build confidence, build competence, and ultimately help us achieve some good results. So remember, we have those 3 big questions. So we have, what's the specific data-driven context? What's the specific context-driven business question? So we've kind of dealt with that part in this video. And then we have 2 other pieces remaining to help us get unstuck. And remember, they are, okay, so we have our question and we have our data. What data come to have anything to say about the question at hand? So we need to learn about data types, how we think about data, how we think about data together as opposed to individual fields. We'll talk about that in a future video. And then after that, we have to think, like, given the data that we have, what are the most appropriate visualizations? So we have to have some mapping between, if I have this type of data, then I think about this type of visualization. And that is a formal, like non-negotiable mapping that we basically just have to practice until we've memorized. So all of this coming up, I just want to put everything, like all these pieces in context in terms of how we actually move through the thought process. So stay tuned for more about data and data visualization in future videos.